Okay, just like many of our friends, oftentimes linear equations fall into special cases. I never fall into a special case, but oftentimes my friends do. Well, with linear equations, it's a little bit simpler than special cases for friends. We can either have equations that have an infinite number of solutions. Okay? In this case, it doesn't matter what you choose, it's going to be a solution to this equation. Or some equations have no solutions. So we're going to look at equations that are both types, one of each, and we'll start with one that has infinitely many solutions. Well, let's start into this equation. It just looks like a perfectly reasonable equation, but I see some simplifying we need to get done. We need to clean that up a little bit. So let's write that as 4k. Okay. Well, there's still a 3 plus over here, and over on the left side there's a 4k plus 3. Okay. And we could carry on with this. We could say, well, you know what? If I'd like to get that 4k out of there, I'll just subtract it from both sides. And we simplify things, and of course our 4k's go away, and we're just left with a 3 on this side. Over on this side, 4k minus 4k also goes away, and we're just left with a 3 on each side. Well, we came down to the helpful fact that 3 equals 3. Well, what's going on with that? That's nice to know, but it doesn't make any sense to us. Well, I want you to look back right here at just this part of the equation. If you look back and read that to yourself, 4k plus 3 equals 3 plus 4k, well, that's pretty obvious because they're equal. Another way you might put it is the left side is identical to the right side. Okay? That's why we call an equation that works out like this an identity. We call this type of equation an identity because the two sides are identical. Okay? So when the two sides are identical, it doesn't matter what you choose for k, you're going to get the same thing on both sides, which is the goal. We're supposed to find something we can put on for k and get the same thing on both sides. If I put a 2 in, for instance, for k right here, 4 times 2 is 8, plus 11 gets me 3. And if I put 2 over here for k, I get 4 times 2 is 8. Add that to 3, you get 11 again. Well, so 2 must be a solution. But I could also pick 1,000. 4,000 plus 3 is 4,003, and 4,000 plus 3 is 4,003. And so it doesn't matter what I choose for k, you get the same thing on both sides. So we would say that there are infinitely many solutions to this equation. Okay? Now let's look at one of the other types here. Now this one is apparently going to have no solution. Let's get started on it and see what happens. Well, I see some cleaning up I need to do right here. Let's get that as 5v plus 10. Okay, so we use the distributive property. Bring our equal sign down, copy down what's on the other side, and we get 5v plus 16. Some of you might be smelling a rat already with seeing the 5v's on both sides. Well, let's jump into this thing again and say, well, let's get rid of this 5v right here. We're trying to clean things up. We'll subtract 5v. And of course, 5v minus 5v, that's gone. We just have a 10 now on the right side. On the left side, well, 5v minus 5v also is nothing. Okay? So I have a 16 on the left side. Well, now I have this statement, 16 equals 10, which is not true, ever. Okay? Doesn't matter. When you look at that, morning, evening, afternoon, 16 never equals 10. So what's going on here? Well, it turns out what this means is there's no number you could put in for v that would make this equation true. I want you to look right back up here at this part of the equation. I've got 5 v's in both places. One here and one there. Okay? If I choose any number for v, doesn't matter what I choose, 5 times that number is going to be the same thing on the left and the right side of my equation. In other words, the two things that I've underlined in red are going to be equal no matter what I choose for v. But then, if I add 16 to one of them and 10 of them to the other, and expecting them to be equal, I'm going to be disappointed. They're never going to be equal. Okay? So 5v plus 16 can never equal 5v plus 10. In other words, there is no number that you could put in for this equation and get a solution. So the answer to this equation would be no solutions. Okay? So you have some types of equations, we call them identities, where the two sides are identical. And so there's going to be infinitely many solutions. And you have some equations that there are no solutions at all because you started out with the same thing and you added or subtracted maybe to each of them differently, and so you're going to get different numbers. Okay? So the way I tell people is this: when you get down to a statement that's impossible, then there's no solution. When you get down to a statement that's true every time, there's always a solution. All right? That's it. Thanks a lot.